All right, we are going to start reviewing for our Chapter 1 test. Our first section that we looked at was 1.3. Our learning target, I can evaluate algebraic expressions. So the very first thing they're asking us to do here is to substitute in a -2 for our x. And in class we talked about whenever you have a negative number that you're substituting in, be really careful that you put in parentheses. So basically I'm going to just take out all of the x's and put parentheses in their spot. All right, then I can substitute in the -2, and then we're going to simplify following our order of operations. Whoops, we need another -2 here. All right, so going through order of operations says to do parentheses first. In this case, the parentheses are there just to hold a spot for our variable. So then we would go to dealing with our exponents. Cleaning this up, we would look at doing a power here. -2 squared would become a +4. So we have -2 times 4. Cleaning this up right here, we have a negative, which turns into a +2. Then it says we're adding 1. Then it says we're subtracting the absolute value of -2, which is a 2. For our denominator, the parentheses again are there just to hold that spot, but if we simplify that, -2 plus 1 would be -1. All right, cleaning up the top part. We do have some multiplication, so we are going to do this part first. -2 times 4 would give us a -8. So our numerator becomes -8 plus 2 plus 1 minus 2. And going through that in order from left to right, -8 plus 2 would be -6. -6 plus the 1 would be -5. And subtracting a 2 gets us a -7. So we end up with -7 divided by -1. Final answer should be just a +7. All right, second question. Standard deviation of a sample is calculated with this formula, S equals, that's a sigma symbol, divided by the square root of n, where sigma is the population standard deviation and n is the sample size. What is the sample standard deviation? If the population standard deviation, which we said was this sigma notation, they are giving that value of 10 and the sample size was 19. So basically they're saying our sigma was 10 and our n value is 19. So our formula says S equals sigma, which is 10, and we need the square root of 19. Okay, using your calculator, we would get approximately 2.294 for that answer. Okay, so again, just a way of evaluating some expressions by substituting numbers in for variables. Our next learning target was I can simplify algebraic expressions. Here, in this case, we're looking at combining like terms in order to simplify this. Notice that we do have some parentheses where we have some distributing to do. So let's do that first. We'd have 3x, -2 times 5x would be -10x, -2 times -3 would be +6, and then we're adding a 7x squared. Combining like terms, we can group our 3x and our -10x together to be -7x. I would accept that as an answer. Typically, we put our terms in order from highest power to lowest. So your better answer would look like this. Your squared terms first, then your x's, and then your constant. For question 4, it says the water tower in Elk River can hold 10,000 gallons of water. Each day, the residents of the town use 300 gallons. Write an algebraic expression to model how much water is in the tower on any given day. So let's let x equal the number of days. In our expression, we are starting with 10,000 gallons, and it says that we are using 300 each day. Okay? So if we use up 300 gallons each day, that means we are subtracting 300 for every day that we're moving forward. All right, with question 5 here, we're looking at a learning target of solving equations. This is actually from section 4. So solving this, again, there is some distributing right here that we would want to take care of. So let's clean that up. Distributing a negative 2 in would give us negative 2x plus 2. Now we do have some like terms that we should combine. So let's clean up the right-hand side here. The 4x minus 2x would be 2x. The 2 plus 1 would be 3. And now when we try to solve this, we need to get variables to one side. So I'm going to add the 2x over. I'm then going to subtract this 3 to get all my constants onto one side. And my last step would be to divide out the 4. And 0 divided by anything is just going to be 0. Question 6 says, when the variable cancels off of both sides, what does it mean if we have 3 equals 3 left as our equation, or if we have 1 equals 2? So let's start with the 3 equals 3. So in other words, we might have started with something like 2x plus 3 equals 2x plus 3. When we try to get rid of those variables, they disappear on both sides. In this case, we are left with a true statement. 3 does equal 3, which means all real solutions, all real numbers would work for that. And we use that capital R symbol to represent that. If we had a statement where the variables disappear and we ended up with 1 equals 2, that is a false statement, which means that there's no solution. All right, a couple more solving equations. In this case, we are looking at solving literal equations. It's a formula that we just need to do some rearranging of. For our first one here, it's asking us to solve for x. I'm going to rewrite this so it's a little bigger for us to see. The first thing to do to get x by itself would be to multiply that 3 over to the left side, which turns into 3z equaling 2x plus 1. So again, what we did here was we times both sides by a 3 to cancel those. All right. The next step, again, we're trying to get x by itself, so we're going to subtract the 1 over. So we have 3z minus 1 equals 2x. And then our last step would be to just divide out the 2. So our answer would be that x equals 3z minus 1 divided by 2. Question 8, it's asking us again to solve for x, but notice that there are 2 places where there is an x. For this type of question, we have to get the x's onto one side. So I'm going to subtract bx over to the other side. So I have ax minus bx minus 2 equals y. Then I'm going to get rid of that 2 because I want just terms that have an x on them on the left side. So I'm going to add the 2 over. So I have ax minus bx equals y plus 2. Now I'm able to factor out an x. Since both terms on this side have an x as a factor, I can divide out an x that leaves me a minus b. And now to get x by itself, I can simply divide both sides by a minus b. So I end up with x equals y plus 2 divided by a minus b. For question 9, I'll clean this up a little bit here. It says the lateral surface area of a cylinder is given by the formula s equals 2 pi r, and it's asking us to solve for r. So s equals 2 pi r. We basically are looking to get r by itself. That means we have to divide out a 2, and we also have to divide out the pi, and we can do that all as one piece. So now the 2's drop out, the pi's drop out on the right side, and all we have is our r. So we'd have s divided by 2 pi equaling r. All right, question 10. It says you have a triangular garden that you want to fence in. The longest side is 4 times the smallest side, and the other side is 4 more than the smallest side. You know that you need 70 feet of fencing to run along the perimeter, so how long is each side? So again, we're just going to sketch a triangle. We are given the longest side in terms of the smallest side. We're given the other side in terms of the smaller side. So let's call the smallest side x. One of the sides is 4 times that. So one side is going to be 4x, and the other side is 4 more than the smallest one. So we have to add 4 to our smallest side. It says we need 70 feet of fencing to go all the way around. So if we add up all of our sides, so the first side, the second side, and the third side, have to add up to 70. Combining like terms, we end up with 6x plus 4 equals 70, and then we can solve subtracting our 4 and dividing. So our smallest side would be 11. That means our next side here would be 44, and our third side would be 11 plus 4, or 15. All right, question 11. It says there is only one freshman in the cast of a high school musical. There are 6 sophomores and 11 juniors. 1/3 of the cast are seniors. How many seniors are in the musical? Okay, so that's what we're trying to figure out. We're going to let X represent the number of seniors. So for freshmen, it says we just have 1. For sophomores, we have 6. For juniors, we have 11. And for seniors, we don't know how many we have. All right, so our total cast, we have 1 plus 6 plus 11, that would be 18, plus this unknown X. So our total cast is 18 plus the number of seniors. The statement here, 1/3 of the cast are seniors. So if we take 1/3 of the whole cast, that should be equivalent to the number of seniors that we have. Okay, now we can distribute a 1/3 to all of the stuff in parentheses, or we could just times both sides by 3 to get rid of it right away. That's probably the easier option. So we end up with 18 plus x equaling 3x. We can subtract an x over to the other side. We end up with 18 now equals 2x, and when we divide, we get 9. So that means there are 9 seniors. Okay? Now, we can check that answer. If we have 9 seniors, dumping that in, that means our total cast would be 18 plus 9, or 27. And they said that 1/3 of the cast is seniors, and 1/3 of 27 is 9. So it does work. All right, moving on to section 5. Our learning target is I can solve and graph inequalities. Our first statements here are just to write an inequality to represent the sentence. So we have to look for some key words. The quotient. Quotient means that we are dividing. It says we're dividing 4 and some number. I'm going to use x as my unknown number. If I take 4 and divide by some number, it's at most 20. So we're looking for what kind of inequality sign would mean at most. If I say I have at most $20, that means I can't go over that. I could have exactly 20, but I can't go over it. So that would say we'd need a less than or equal to. 4 divided by x has to be less than or equal to 20. The second part of this, it says the difference. Difference is when we are subtracting. The difference between some number, we'll call x, and 5. Okay? The difference between some number and 5 is greater than 20. So let's start with this. Difference of a number and 5 would be x minus 5. We know it's related to 20. It says it is greater than, so we know we need a greater than symbol in there. All right, writing and solving compound inequalities. This is where we have our and types and our or types. We have to pay attention to that. So our first one, we have 3x plus 3 is greater than or equal to 2x, and at the same time, we need 3x to be less than 12. So going through and solving these, for the first one, I would subtract the 3x over here. We have 3 is greater than or equal to a negative 1x. And when we divide by a negative, remember we have to flip that inequality. So we have negative 3 is greater than or equal to x. We can turn the whole thing around if it's easier for us to read it that way. We can say x has to be less than or equal to negative 3. Okay, on the other side, we have this inequality 3x is less than 12. When we divide out our 3, we've got x is less than 4. Okay? So we have a statement that x is less than or equal to negative 3, and x has to be less than 4. I feel like I've missed something here. All right, I apologize. I made a little mistake here. We talked about flipping the inequality, and then I never flipped it. So right here in this step, when we divided, we should have flipped this over. So this should be now x is greater than or equal to negative 3. I apologize. All right, in terms of graphing this, our key numbers that we would want on our number line would be a negative 3 and a positive 4. We want x to be greater than or equal to negative 3, so we should have a solid dot going this direction. And then we also want x to be less than 4, so we have an open dot here, going this direction. So we should be looking at all of the values that are negative 3 and higher, and then stopping just before the 4. All right, for question 14, again, we are dividing by a negative 2. That tells me that my inequality sign has to flip, so x has to be now less than negative 5. Or, for our second part, we would subtract a 1, so 3x is greater than or equal to 6, and then when we divide, we'd have x is greater than or equal to 2. So the key numbers on my number line, I need a negative 5 and a positive 2. I want to be smaller than negative 5, or I can be at 2 or higher. That would be my final graph. So again, we are looking for a solution algebraically as well as graphically. All right, question 15. We are looking at section 1.6 here, where we can write and solve equations and inequalities that involve absolute values. We talked in class about absolute value, the analogy of breaking out of jail. So we're thinking about these as our jail cell bars, and we have to get rid of those guards. So my first step would be to get rid of the guard that's at 9. And then we are looking at a statement that says the absolute value of something equals negative 4. Well, absolute value, whatever we put in here, is going to come out as a positive number. There's no way it can end up being a negative. So right away we can say there's no solution. We don't have to keep trying on that one. All right, we're going to cut out this part of it. We're just going to solve this. We've got 2 times the absolute value of 2x plus 4 minus a 7 equals a negative 5. Now notice that there is a negative 5 here, but we have to be careful. We have to get rid of all those guards first before we determine if we can solve this or not. So we've got 2 times the absolute value of 2x plus 4. I'm going to add the 7 over here, so it turns into a 2. I can then divide both sides by 2, and I have the absolute value of 2x plus 4 equals 1. Now I can break out of jail into my 2 equations. So 2x plus 4 could equal the regular 1, but it could also be a negative 1, because when I take the absolute value of negative 1, it would turn into a positive 1. All right, to solve this, we're going to subtract 4. So 2x equals negative 5, and then we're going to divide everything by a 2. We've got x equals negative 5 halves. On the other side, we're going to subtract a 4 again. This time 2x equals negative 3, and when we divide, we get negative 3 halves. So 2 solutions, a -3/2 and a -5/2. All right, question 17 says to solve and graph. Notice that this time our absolute value is an inequality, and we have to pay attention to whether it's a greater than symbol or a less than symbol. Remember greater, we talked about this being the or type where it's separate statements. Less than, we talked about these as being the and statements where we can combine it into one compound inequality. All right, so solving. First thing I would do on number 17 would be to add the 3. Now I have the absolute value of 2x plus 1 is greater than or equal to 5. I can break out of jail here, but greater means I need 2 separate statements. So 2x plus 1 could be greater than or equal to 5, or 2x plus 1, when I change it to being a -5, remember we have to flip the inequality. So 2x plus 1 could be less than or equal to -5. We're trying to go farther away from 0. All right, solving these. I'm going to subtract a 1 from both sides and then divide by 2. So we have x is less than or equal to -3. Or on this one, I'm going to subtract a 1. So 2x is greater than or equal to 4. And dividing, we've got x is greater than or equal to 2. So the key numbers I need on my number line would be -3 and +2. I would use a solid dot on both because there are equal signs with the inequalities. I want to be greater than 2, or I want to be smaller than -3. On your test, you should have, for the algebraic way of giving an answer, we have this with this word in between, and then this. All right, question 18. Notice that there is a guard, that 3 that's in front, so we need to get rid of that first. If I divide it out, the 9 turns into a 3. Now we're looking at a less than. Okay, so this is an and situation. We want to be closer to 0 than 3 spaces. That means I can be anywhere in between a -3 and a +3. So I need to figure out when x minus, keep writing a plus sign, sorry, when x minus 5 is in between the -3 and the +3. So adding 5 to each of these inequalities, we have x having to be in between a 2 and an 8. So on my number line, I need a 2 and an 8. In this case, I would want open circles because I'm not equal to those endpoints. And I want my x's to be everything in between. So greater than 2, but at the same time less than 8. All right, our last question. It says a 10-pound dumbbell will pass inspection if it is between 9.95 pounds and 10.05 pounds. What is the tolerance of the weight of the dumbbell? And what absolute value inequality describes the acceptable weights of the dumbbell within the indicated tolerance? To calculate tolerance, we take the maximum allowed minus the minimum allowed and cut it in half. So if we worked through this with the specific numbers we're given, 10.05 minus 9.95 divided by 2 ends up being 0.05 or 5/100ths of a pound. So we are tolerant of that weight being anywhere either 5/100ths above the 10 pounds that it's marked or 5/100ths below that. Our absolute value inequality is always our variable minus the desired amount. And in this case, we wanted that dumbbell to be 10 pounds. So we'd have x minus 10 in absolute value. And we are saying we can be within a tolerance of 5/100ths. Now, if we went about solving this, we would say x minus 10 because it's less than. we are putting it in between the negative version and the positive version of our answer. And when we add 10, we can see that we can be anywhere from 9.95 up to 10.105, which is what they told us in the question. Okay, so this would be your answer, your absolute value inequality that they asked for. This was just to check to see if we had it set up correctly. All right, let me know. Send me an email if you have any questions or would like a Google Meet.